Before we actually get into the today's aspect of how we develop a MapReduce application, I would like to give a brief introduction towards what is big data and how big data is connected to or related to Hadoop. Let us try to understand this relation and see how we understand this and then move to the next level of developing a MapReduce job.
Yeah, I'm logged.
So we try to understand what is big data and how big data is connected to Hadoop, and then we probably see how we develop a MapReduce job. Because in our earlier webinars we have given the concepts in detail about big data, Hadoop, and working with HDFS and all that stuff. If any of you are truly new to this big data, I advise you to go through our earlier webinar so that it will be more meaningful. But to give the introduction towards MapReduce and develop a MapReduce job, we want to start with the concept of big data. That is where we want big data to be introduced before we start writing the MapReduce job. So hope you are all aware what exactly big data is, both from the industry perspective and even your personal perspective. Big data is anything which has got certain characteristics, essential characteristics. Is anything which has some essential characteristics. Before we talk about big data, it's good that we understand what is data and why data is so important in the context of big data discussion. So as a part of that, I'm trying to give you, have a look at this slide. Then you'll be able to understand why we actually need to focus on something called data. At the very lowest level, we have something called data. When it has been processed, we get something called information. When information is further synthesized, we have knowledge. And knowledge is further synthesized, we acquire wisdom. With wisdom only we make the decisions. Either right or wrong, it is all with the wisdom. So at the very lowest level, we have something called data, which when being processed, we have something called information. And information leads to knowledge, knowledge leads to wisdom, and with wisdom we make the decisions. So this clearly depicts, or this is in fact popularly called as DIKW model. We actually call this as a DIKW model. This is called as DIKW model. That is called data, information, knowledge, and wisdom. Imagine if there is no data, we can never get information. Without information, we will not have knowledge. Without knowledge, there is no wisdom. And without wisdom, we will not be able to make any decision. We will not be able to make any decision. So in order to make a decision, we definitely need wisdom. and that is always acquired through the knowledge, and which in turn is acquired by churning the information, and information is always the result of processing your data. So data is proved to be the foundation or the fundamental. It is a foundation to this model, that is a DIKW model: data, information, knowledge, and wisdom. So without data, you will not have all these things in place. So it is a clear thing from this slide that data is essential or data is crucial. Without data, we will not be able to make any kind of decision to put the organization in whatever the track. So now it is the time to talk something about what is big data. Big data is anything which has got three essential characteristics. Volume, velocity, variety, and velocity are the three essential characteristics with which we define something called big data. So big data is anything which has got three essential characteristics: volume, variety, and velocity. You look closely, you understand this volume and variety are linked with your storage, and your velocity is linked with your processing. So your big data is going to throw a challenge. When you get a huge volume of data, when you get wide varieties of data, where you are going to store this, where you are going to store the data when you have huge volume and wide varieties? That is the first question which your big data is going to challenge. The question is, when you have huge volume and wide varieties of data, where you store that? When you have huge volume and wide varieties of data, how quickly you are going to process that is a second challenge that your big data is going to pose. So your big data is said to be a problem statement. Why your big data is said to be a problem statement? Because it is challenging when you get a huge volume and wide varieties of data, where you store that. Imagine that you stored the data, huge data and wide volume, wide varieties of data. Then the next question is, how quickly you are going to process that huge volume and wide varieties of data? How quickly you are going to process that stored data is the next challenge. So in order to resolve these challenges, we have something. I hope you have understood what I am trying to share with you here. So these challenges are being addressed using, and that is what the relationship that exists between big data and Hadoop. I hope you are able to understand clearly what is that we initiated. So we started our discussion with what is big data. In order to understand what is big data, we thought of understanding what is data first. So we understood what is data. Then we added big to that data. Then we have understood what is big data. And as a part of understanding what is big data, we found the two challenges that are being raised by big data, one in the form of storage and the other in the form of processing. Your storage is addressed using your HDFS and your processing is addressed using your MapReduce, and MapReduce is backed by massive parallel processing technique. That is what we call it to be MPP, massive parallel processing technique. So MPP I mean massive parallel processing. We are going to see this one probably in the next slides to understand what is this massive parallel processing. So a typical Hadoop cluster is going to look something like this. A typical Hadoop cluster is going to look something like this. Definitely you might be aware that Hadoop is a master slave architecture where you have master node and the slave node for every uh, aspect of your big data. I mean your big data is being broadly into two parts now. I mean your Hadoop is into two parts now. One is your storage, that is in the form of HDFS, and the other one is your MapReduce, which is nothing but you call it as a module or you call it as a framework. We technically call these as frameworks. Your HDFS is meant for storage and your MapReduce is meant for your processing. So I think you are clear with whatever we discussed now. So hope you are clear with whatever been discussed here. So your HDFS, which is meant for storage, and your MapReduce meant for processing. In the last webinar, we have discussed very in detail about HDFS, how the commands can be used and all that stuff. I just want to briefly recap a couple of the commands that we worked in the last discussion before I take things forward. Like how you run your Hadoop, I mean your normal Linux commands, like saying ls -al ls /. These are all the commands that you run against your Linux box. Same like Hadoop fs-ls, I say this is going to give me the Linux file system. Sorry, this is going to give me the Hadoop distributed file system. So whatever been shown before, this is what your traditional Linux file system, because I connected to my Edge node. I've explained how my cluster is being set up. This is a 7-node cluster we have. We have a 7-node cluster, out of which one node is for your name node and one node is for your resource manager, and we have a 5 data nodes, and these are called the masters, and this is what we call it to be the slaves. So depending on my requirement in the coming days, I can go with more data nodes. I can keep on adding the data nodes. So if my storage need increases or if my processing need increases, then what I do is I keep on adding my data nodes. So today it is a 5 data node cluster, but if demand arises, I can add one more node, keep adding. Like that today, as of with Yahoo, the highest Hadoop cluster running, around about 65,000 nodes. That's what the latest information we have. 65,000 data nodes live running with Yahoo Hadoop cluster. Still the number is growing, but still your name node is able to withstand, is able to manage all the data nodes that are being connected as part of the cluster. So in order to access your Hadoop distributed file system, I take the help of my Hadoop file system client. When you say Hadoop at the terminal, where your Edge node, I got connected to the Edge node now. When I say Hadoop, these are the different possible things with Hadoop. One is your FS, that is called your, in order to run the generic file system user client. So I say here Hadoop fs-ls. Now same like your Linux, ls/. Whatever is being shown down, this is what we call it to be your Linux file system. That is nothing but the Edge node Linux file system. Whatever being shown here, this is what we technically call it to be my This is what we technically call it to be my Hadoop distributed file system. Hadoop distributed file system. At my root level in my Hadoop distributed file system, I have all these things. Same like you see Hadoop FS -ls. So by default, your Hadoop FS-ls is going to show you the file system that is accessible to the user who has logged in. What is the user that I logged in now? The user that I logged in now, let me connect it once again. Or I open a new terminal where I'm getting connected to Srini, and with my credentials I logged in. So here, if I say who am I, this is Srini. So this is the account that is available to me on my Edge node. I also have got the account on my Hadoop cluster with the same name, that is Srini. So when I connect to my Edge node using the credentials, that is Srini and my passcode, I am able to Hadoop FS-ls. I say by default, like how when I get connected to my Linux file system, by default I go to my home, that is user home. That is what I say here. The user home is this one. Whichever the user is logged in, by default you are being taken to the home, that is called user home. So when I say ls, it is going to give me the file system present on my local file system, that is my default home. Same like at my Hadoop cluster also, I'll be having the user account there even at my Hadoop cluster, which I'm trying to show you here, friends. I think you might have noticed that here. So this is my, I think you noticed. So you have your, I think you see here, this is user Srini. Every user that is created at the Hadoop level will have an account. Like how you create the accounts, even here you have the provision. I think you have the option here, manage users. So here I have the option called add user. I am able to create a user at my Hadoop level also. Like how I am creating the users at my Linux box, I'll be able to create my users at my Hadoop also. So whatever I am trying to show you now, that is what the file system that is default accessible to my account, that is Srini, user Srini. So as part of that, I have these two files been kept. One is Mary and the other one is the directory that has been created by running my MapReduce job. I think you noticed here. I hope you are clear, friends, what I'm trying to share with you. Make sense? So I'm able to access my file system. Hadoop FS-ls. By default, it shows you the default file system accessible to your user account. The user is Srini. Who is submitting this command? Hadoop FS-ls. Who is submitting this command? This command is submitted by the user called Srini. So with that user, what file system is accessible by default, that is being shown if you don't specify any path. But if you specify any path, then it is going to show you under that path what file system is accessible. You also can see here under user, if you see, you have these level of, I hope you are seeing, Hadoop FS-ls/user/Srini. If I say that, it is going to show me what are the files that are accessible to me. So even without that path, without that, if you give Hadoop FS-ls and I just press enter, it is going to show me the file system that is accessible to me by default for the user who submitted that command. So I advise you to go through these file system commands, friends. When you go to hadoop.apache.org, you go to hadoop.apache.org and you go to learn about, then you will be seeing how you can access your file system. That is what file system shell. All the commands that are possible from your file system shell, all these commands can be executed, out of which you have ls here. How you can use ls, they are showing you very clearly. They are also giving you the brief explanation about how that command can be used. So you can see that here. Hadoop fs-ls, Hadoop fs-lsr, Hadoop fs-mkdir, how each command can be used by you as part of your file system at your Hadoop level been shown here. So I advise you to go through this documentation to understand how file system client can be used by you to run your file system commands against your Hadoop cluster. The 7-node cluster what have been set up by us, how we are able to access the file system. I'm trying to show you here. Now imagine the data, you have got the user account and you have the data loaded inside your Hadoop file system as part of your HDFS, everything been ready. So what is the theme of going with what is the theme of going with your Hadoop cluster is? It's very clear. So want to store your huge volume and wide varieties of data, because your HDFS is not like your traditional Rdbms, where your traditional Rdbms, if you take all these traditional Rdbms are schema first storages. What do you mean by schema first storage? You need to first define the schema, the definition, and pertaining to the definition only you will be able to push the data into your storage. Because Rdbms is also a kind of storage only. So what is the need we are going with storage? Ease of storing the data and ease of retrieving the data. That is the reason why we go with Rdbms. There are reasons why we are going with Rdbms and there are limitations with Rdbms. So as we have limitations with Rdbms, that is the reason why we are compelled to come to HDFS. So few of the popular limitations with your traditional Rdbms are, with your traditional Rdbms you can only store limited amount of data. You can only store limited amount, not like how you can store with HDFS. Beyond some manageable limit of the Rdbms, you will not be able to store. That is why periodically what we do is we are going to take the backup. We are going to take the backup of the data and clean that and make your Rdbms free, so that your new data can be loaded in, or your transactional data can be stored in your Rdbms. That is the reason why if you go to any bank, typically you ask them to give the bank statement of 5 years back or 7 years back. They say they need time, because all the data which is been archived, the historical data which has been archived, we need to go to the library, identify the suitable archives and load the data and then generate the reports and then again archive it. So there is a lot of process that is back office processing involved in generating your statements of the earlier dates. So the limitation with your traditional Rdbms is the allowance of the storage of data or the holdability of the data. That is one thing. And the second thing is your Rdbms allows only the specified data. That is the reason why we call this to be schema first pattern. We define the table. Based on the table definition only we can store the data. We cannot store the data anything other than the definition that is being made. So we cannot store the data which is other than what is the definition. So that is what the true limitation you have with your other than the definition that is being given as part of your table definition. If you try to store anything other than that, immediately I mean, you issue the command insert into the table, whatever the table, EMP or whatever, and you specify the data which is not being defined at the time of defining the table, then it's not going to allow you to store that. So that is where we call this as a schema first. Unlike your traditional RDBMS, your HDFS is going to allow, I should not use the word called unlimited, but practically as and when your storage need increases, you just keep on adding the nodes. So I can practically say you can store any amount of data. So your limited restriction is being relaxed when you come to HDFS. Any amount of data can be stored in your traditional, in your HDFS compared to your traditional RDBMS. And the second, unlike your traditional RDBMS where you have the schema first patterns, your HDFS is not like that. HDFS practically allows any kind of data to be stored because your HDFS is not going to come with any schema. So like how your hard drive is, same like your HDFS storage. Like how your hard drive is going to allow any kind of data to be stored on it, your your HDFS is going to allow any kind of data to be stored. Let it be text data, your executable data, your PDF, document, images, your video, audio, your data coming from your traditional IoT devices or various sensors. So all the three varieties of data what you have, semi-structured, unstructured, and structured, all three can be. Of course, structured data you can conveniently store in an RDBMS. You don't have any speciality when it comes to HDFS. You can store even structured data. But HDFS is not basically meant for structured storage. HDFS is basically meant for semi and unstructured storage. So the traditional practical difficulties what you have with your RDBMS can now be comfortably eliminated with your HDFS by making the data to be, I hope you are able to understand, friends, what I'm trying to share with you here. So your traditional RDBMS limitations can be overcome comfortably with your HDFS. Now, that's what the beauty part here. When I say here Hadoop FS-LS and I say /, it is showing you a single file system. You never know how many nodes we have in the background making your Hadoop cluster. You never know that. You always feel like how your traditional file system on the Linux box, ls you say how it is listing you the files present on your Linux box. In the same way, your Hadoop distributed file system is also being accessed using your Hadoop FS. It is giving you the access to your file system. So you need to understand this one. But practically, if you see, I have 5 nodes in the background. 5 physical machines are there in the background which are making my Hadoop cluster. But you never come to know how many machines are there in the background because you are accessing the file system in a similar way like how you are accessing your traditional Linux box. I hope you are clear with this, whatever I have discussed. So this is all about my HDFS. More details about this, I advise you to get in 2 ways. One, you go through my earlier webinars. You will be able to understand how you can work with your HDFS, how you can run your file system client and run your Hadoop commands. And then is your MapReduce. The second one, what you have as part. MapReduce is a backbone for your Hadoop cluster in terms of processing the data so quickly. The reason behind, I'm going to show you a couple of slides to make you to understand how you are able to, how you are going to process your data using your MapReduce. I would like to share that with you here. Have a close look at this, then you'll be able to understand. See, this is how your data is being stored. When you say Hadoop FS -copy from local and you try to store the data, your data is being stored and is being replicated. All those aspects been covered in the earlier webinars. Please go through them to get better understanding on it. So when it comes to your MapReduce, have a look at this, friends. You'll be able to understand. Have a look at this. As a client, when I submit my job to my job tracker, your job is being received by the job tracker and is being pushed. You can see that here. When the client submits the job to the job tracker is going to understand what is the command that is being given by you. I would like to give you the command. Please have a look at this one, friends. The command that I use in submitting my job. Like how I have Hadoop FS, I have something called ZAR, Hadoop ZAR. I say Hadoop ZAR, and where my ZAR file is located, I'm going to specify the path. And in that ZAR file, if I have multiple jobs being exported, then I need to specify which job needs to be executed. Maybe I specify simple word count and where my data is present on my HDFS cluster, that is user/Srini/Mary is a file which I want to process. When my job is going to process the data present inside this directory, I need to specify where the output needs to be stored. I specify Mary_out, something of this sort I give. So this is, you call this as a command, or you call this as a statement, or you call this as the process to submit your MapReduce job. You call in the way you feel comfortable. But this is how you are going to submit the job to your cluster. When the job is being submitted to the cluster, immediately, this is how you submit the job to the cluster. When the job is being submitted to the cluster, your job tracker is going to immediately talk to the name node to understand whether the given input path really exists or not. Whether the given input path really exists or not. Whether the given input path really exists or not. If the given input path does not exist, then you are going to have, say for example here, I say some file, and I press enter, is giving me the clear indication one second. So when you see this one, it is giving you the clear indication. The input path does not exist. It is telling you very clearly that the input path does not exist. So you understand from this whatever I am trying to give you here. When you submit the job to your cluster, your job tracker is going to talk to the name node to understand whether the given input path exists or not. If the given input path exists, it says okay. So whatever the data I need to process, that data is really available, or the user is specifying the right path to be used for processing the data. That is one thing. And the second thing, whether the given output path exists or not, that also it checks. Now see here, if I give like this, it is giving me the exception saying that the output path already exists. So it is a clear indication that whenever you are specifying the output path, this output path must not exist. For any reason, if this output path exists, then what the job tracker will understand is, it will understand that in that directory, there is an output which is already been stored by some other job which got executed before. Maybe some other user, or maybe the same user might have executed some MapReduce job in the past, As a result of that, the directory got created and the output is being stored there. Now, if the same path is being again given now, if it is being used, it may override the existing directory, which may override the output of my earlier job execution. So in order to protect that, the output path must not exist. The output path must not exist. So your job tracker is going to talk to the name node very clearly whether the given input path exists or not, whether the given output path exists or not, been verified. Based on that, it allows the job to be actually submitted to the cluster and the actual processing is going to start. When the processing starts, the job tracker is going to receive that jar file and push that jar file to all the nodes where my data is present, and my data is going to be processed locally. As a result, I am able to see how my MapReduce job execution is going to take place at my, how it is going to take place. Have a close look at it. You'll be able to understand. Even in the last webinar, I clearly mentioned that this diagram needs to be printed in your mind. Then only you'll be able to understand how your MapReduce job is actually going to be executed. How your MapReduce job is going to be executed. Your MapReduce job is going to be executed in the fashion that I am showing you here. I hope you are able to see the screen what I am sharing with you, friends, here. Have a look at this slide. So you look at this one closely, then you'll be able to understand that how your MapReduce job is getting processed in the beneath layers. You'll be seeing that one here very closely. When the job is been submitted, your job is going to undergo the processing. The job is going to undergo the processing. Your input format, based on the input format, the splits are being decided, and each split is expected to be processed by the record reader. The record reader is going to read the records and give the key value pairs to the map function, and each split, when being processed by one mapper, you get some partial output, and when this split is processed by one more mapper, you get one more output, and one more split by one more mapper. So within this node, I am able to see there is a parallelism. I think you are able to notice very clearly there is a parallelism within this node. I mean, when my split 1 is getting processed, or my split 2 is getting processed, split 3 is getting processed, all these three will get processed parallelly. They are not going to be processed one after the other. All get processed parallelly. They are not going to be processed one after the other. Now, when the processing is happening inside my node 1, the processing also happens parallelly inside my node 2. And that is what we call it to be. Within the node, there is a parallelism. Across the nodes also there is a parallelism. And this is what we call it to be parallelism inside parallelism, which we technically call it as massive parallel processing, which is a backbone for your MapReduce framework. I hope you are able to understand, friends, what I am trying to share with you here. What is massive parallel processing? So massive parallel processing is the technique with which you are going to process the data very fast. Now, as been mentioned by me clearly, that in the today's discussion, our goal is to understand how you are going to work with your MapReduce job development. Friends, I hope you are all aware how you are going to work with Eclipse. So this is what my Eclipse IDE. So I expect that every one of you has got some basic understanding of how to work with Eclipse. Eclipse is basically the IDE. Using this IDE, I am able to develop my MapReduce job. So in order to develop my MapReduce job using this IDE, that is Eclipse IDE, integrated development environment. This is the editor where all the essential things are being integrated for the sake of developing your MapReduce job. So Eclipse is being used not only for this, for wide varieties of purposes. You can use Eclipse to develop your Python projects, your PHP projects, JavaScript projects, your web applications, enterprise applications. Using the same IDE, Eclipse IDE, you can also develop MapReduce jobs. So for that sake, what needs to be done is, you need to download Eclipse. You need to download Eclipse from eclipse.org because it's a free downloadable. And you set up Eclipse, easy to set up. Once been set up properly, you run that and you should be able to see what I am showing you here. This is what my Eclipse ID. This is what my Eclipse ID. I go to my file and I say new. I click on Java project. You give whatever the name you like. Maybe you specify something called first MR job. I hope you're getting the point what I'm saying. You want this project to be created in other place other than your default location. Default location is what we call it to be workspace. Your Eclipse workspace, that is what we call it is Eclipse workspace. When you start the Eclipse, it is going to start with some workspace only. So you want your project to be created in the location other than the default. Then you can uncheck that and you can browse the location and you can create the project wherever you want. You can create the project wherever you want. Now I'm using the default location, and good that you make use of the appropriate version of the JRE. Preferably good that you use 1.6, preferably 1.6. Maybe 1.8 is available, even 1.9 is available on your machine. But you need to understand the incompatibility that is going to be arised when you submit the MapReduce job to the cluster where the environment of the cluster is different. I hope you understand what I'm trying to share with you here. So here you see, you understand Java-version. You see, no issue. So Java is not available on this. That's fine. Let me connect to SSH Srini at DM1. Not an issue. Sudo su root SSH root at dn1 Java Interesting. Slash root slash user slash Java. Um, You have a look at this one, friends, that we have JDK version the 1.7 that is being set up on your boxes, because every node inside the cluster, is being set up with Java, without which your Hadoop environment cannot be set up at all. So that is all a part of the installation process. We need not worry. To make you to understand, I'm just showing you. Now imagine that you create this project with JDK 1.8 or JDK 1.9 or something of that sort. Then when you develop the job using the higher version of the JDK and try to run against the lower version, is definitely not possible. You come across incompatibility issues. Not to happen this one, it's always a good practice that you make up with JDK 1.6 or Java SE 1.6, and that's going to be a good choice. But 1.5 is too primitive, but 1.6 is good enough that you make up. And again, you need to make sure what version of JDK is being set up at the time of setting up the cluster. Of course, it is being shared with every developer who is going to work on the Hadoop cluster. What version of JDK is being set up on the cluster? Based on that, you can decide at the time of creating the project what version of Java SE needs to be used. Use an execution environment that is JRE 1.6. I hope you understand what I'm trying to share with you here. I say next. So I'm having my first MR job and a SRC folder going to be created. You want any additional things, then you can always do that, but I don't need anything as of now. And I have my binaries to be stored inside my first MR job / bin. I just click on finish. When I say finish, I need not tell you what is going to be created. The basic infrastructure needed for your Java project is being created by your Eclipse. When you go over here and you see, you'll be noticing you have something like this here. This is what your folder structure. So you have your JRE system library been set up to 1.6. You create any sources that is going to be kept over here. Probably here I go and I say the new Java class. Maybe I say here word count. And I want the main method also to be there here. I don't need any constructor. So package, I want to keep it as com.techiebees.mrjobs is what the package I've given. I want the comments also to be generated. I just click on finish. This is what the default skeleton to your word count class that is being. In the last class, I have already explained you. Last webinar, I have explained how you can create your how to understand your MapReduce job. I'm just going over here and copying the code. I'll try to explain you once again MapReduce job. And I say here, I take out this part and I copy it over here. And I take out this package statement because I have already the package statement there. Yes. And I call this as my word count because I made this class as a Public class, public word count. You know very well that inside a file called wordcount.java, if you keep any public class, that class name and this file name must be the same. If this is not a public class, then you can give any name. That is up to you. But in any typical .java file, you can have only one public class, and that class name should be the file name. I hope you understand these basic semantics of Java. Now the big challenge and the big question that we need to understand. All these classes that are required for your application, for your word count application, they are available in the ZARs that comes as part of your Hadoop setup that you do it on the cluster. So those ZARs needs to be included inside your project. This is what the sensitive and the typical thing that needs to be observed here. Till now, whatever we did, creating a Java project and creating a Java class and keeping a mapper inside that, keeping a reducer inside that, and having a main method inside it, and writing the code. This all is fine. Anyone who has some basic knowledge of Java can easily understand what is that we are trying to do here. But if you see, it says import cannot be resolved, which means the ZAR file which actually contains this class is not available as part of this project. So you need to add all the respective ZARs in order to make that possible. So what I do is I go to my project, I right click on that, and I go to my build path, and I go to my configure build path. When I go to my configure build path, I have something called libraries, and I have something called add external ZARs. Add external ZARs. So I go to my place where I have kept all my ZAR files, client ZARs. I add all these ZARs to my project and I say apply, and I say now you go back to the same, all been resolved. There is not even a single issue with the source file what you have here. I hope you are able to understand. Now the big question here is, Srinivas, where we get all these ZAR files? Usually these ZAR files are going to be kept in the repository, in the local repository, or some accessible space in the development environment. And these files are actually available in your, let me show you, slash opt slash cloudera slash parcels slash cdh. If you go over there, you see something called lib, and in that you see something called you have all these directories available, out of which there is something called Hadoop-MapReduce. I go over there, Hadoop-MapReduce. I say here, now I think you noticed a lot of ZAR files that you see here. A lot of ZAR files, I think you see here. Either this way we can get, or this is a place where you see, all the required libraries, I think you notice here you have something called Hadoop CD, Hadoop. You have 0.MapReduce, where you see lib. You have all these ZAR files. You can get it from any of these sources. Usually what we do is these ZAR files are being copied and being kept as part of a repository, the development environment, and that is being made accessible to every developer who is working on the MapReduce job development. So they can access those things. That is how even I got. How I was able to get those ZAR files is from the repository, and I copied onto my local file system. I think you noticed here, I got those things as part of my T work, and in that I have something called MapRed. I have something called client ZARs. All the needed client ZARs to develop a MapReduce job, I kept it here, and I was able to. I think you noticed here Hadoop-HDFS, Hadoop-MapReduce-client-app, Hadoop-yarn-API. So you have all these ZAR files available as part of your client ZARs directory. This client ZARs directory is what is been created by me. That's not been implicitly created. So I am maintaining all my required ZAR files to develop my MapReduce job inside this folder. So when I configure my build path, I think you notice here, I go to my project, I right click on that, and I take to configure build path, and there I go to libraries and I say add external ZARs. Where my ZARs are located, I select all those ZARs and I say open. All those ZARs can be added to your project. Now I think you are able to understand. If you go to this and see, if you go to this one and see, you have your Hadoop, all the stuff that is available here. I think you notice. I'll be showing you the reference libraries. In the reference libraries, if you go and see, you see something called Hadoop. Yes, I think you notice here, friends. or.apache.hadoop.mapreduce. In that I have my class called mapper class. I have my class called reducer class. I have my class called partitioner class. I have my input format. I have my, all the classes are present inside this ZAR file, which I'm using as part of this. Truly speaking, I just need this ZAR file. Only this is sufficient to me. Only this ZAR file is sufficient to me. But I need the other ZAR files for the reason this library is going to internally make use of the other libraries. That is the reason why we need to add all those ZAR files, though we don't need those ZAR files directly as part of our MapReduce job implementation. But we need the other dependent ZAR files, because internally your or.apache.hadoop.mapreduce is going to make use of the other libraries. That is the reason why you require the other ZAR files that are being added here. So once you add this one, you'll be able to resolve all the dependency issues. All the necessary classes are being successfully been brought into your project, and all the issues are being resolved. And now I go to my project and I right click on my project and I say export, and I say ZAR, and I just click on this one and I say where I want to create my, maybe here in the MapRed, I say my or first MR jobs is the name what I'm giving. So you can see that here in this place I have my ZAR file created. I mean, not been created now. I'm going to create that now. Say next. I say next. I need to specify what is the main class. Word count is the main class, and I just click on finish. Then what is going to happen is my ZAR file is created in the path where I think first mr jobs.zar is created here just now. I think you notice 7:43 p.m. 30th August 2018. This ZAR file is being created. So you understand with this how I create my project in my Eclipse, how I add my required libraries to my project, how I'm going to resolve all the dependencies. And this word count program, you can get it even in the internet. You need not worry for that, friends. You can just copy paste and see it. But what all the other process that I've mentioned, that is essential for us to work with the project creation. With this, what has happened is I was able to create my project. I was able to create my Eclipse project in my I was able to create my Eclipse project, that is basically a Java project, and to this Java project I have added all the libraries, and these libraries are usually shared with every developer working on the MapReduce part, and these libraries are actually being bought from Hadoop Cluster only. From Hadoop Cluster. You cannot download whatever the libraries you like it from the internet. Of course, you can do that provided you know the exact version of the Hadoop cluster that is being set up on your the exact Hadoop cluster that is being set up on your on your environment. And if you know the exact version of the Hadoop cluster that is being set up, you can also download the jar files from the internet. That is fine, but it is always advised that you get these jar files from the Hadoop cluster, and those being kept in the common accessible place, usually the repository. From that repository, every developer is going to get the jar files and being stored locally. And whenever you are creating a new Eclipse project, you identify where these jar files are located, and those jar files are being added to your Java project. So once you add all the required jar files, you will be able to create your MapReduce job and able to access all the classes that are required for any basic minimum MapReduce job that you develop. So you are able to create a Java class, that is what is being shown here, and all the dependency issues are being well addressed, and you are able to successfully export this Java project. You are exporting this Java project, export this Java project as a .jar file, and you also need to specify what is the main class. So you need to specify the main class because of the reason when you are submitting this job to the cluster, you need to tell what is the initiation point of this jar file. I mean, what is the main execution point of this jar file. So that is the reason why you need to specify the main class. Now the story is not over. So what needs to be done is this jar file, I need to port it to my, have a look at this one, friends. So from my local box, what I'm trying to do is in my twork, I have something called mapred, and I have something called my first. I copy this into my Linux box. This is my edge node. If you observe this one closely, friends, on my Windows box, I am developing my MapReduce job, which I am copying into my Linux box, that is my edge node. Then only I will be able to, I think you notice here, friends, what I'm trying to share with you. You can see that here. You can see that here my first mrjobs.jar file is been copied to my edge node. So altogether, there are three things that are involved here, which you need to understand. My developer machine, this is dev machine. This dev machine is what my Windows box. On this only I have my Eclipse, and that is where I created my project and all. So that needs to be copied to my edge node. That I need to copy to my edge node. So only when I copy to my edge node, I will be able to get the opportunity to say Hadoop zar. I say first mrjobs.zar and I specify /user /srini /mary and /user /srini and I say Mary underscore out 2 or something like that. And this is going to be done. I hope you are able to understand, friends, what I am trying to share with you here. So if you say this, I think you see very closely here. You see closely here, your map been executed, your reduced phase been executed, and your job been successfully executed, and you are able to see the expected outcome, and you got your files created. This is all how you write your MapReduce job, and how you get that MapReduce job into your edge node, and from the edge node, that is how you are going to submit to the cluster and make your job to run successfully and get your things done. I hope, friends, you are able to clearly understand how we were able to do all these things as part of this one. You have any questions, please feel free to ask so that I'll be able to address those things. You can unmute yourself, friends. You can unmute yourself, and you have any questions to me, please feel free to ask so that I'll be able to address those things.